We're going to look at some problems with grouping or taking a letters or objects and arranging them in a different ways and looking at the possible options. Let's look at something simple first. I know that you've done enough examples with it, but let's start with the word maths. So we have 5 letters that we need to arrange. So if you think about it, you've got a word, mathematics, or just maths in short, and we have 1, 2, 3, 4, 5 different objects to arrange. And if the question is in how many ways you can arrange 5 different objects, whether those objects are 5 different books, 5 different letters, 5 different digits, it is still 5 objects. Therefore, the total number of ways in which we can arrange the object is 5 factorial ways. Now you can use your calculators to determine the total value, because in the exams we cannot leave our answer as 5 factorial. I know this is quite simple. So 5 different objects, 5 different letters in a word maths can be arranged in 5 factorial ways. But now if I take my letters, okay, and I want to arrange them in, look at that, in such a way as letters H and S are grouped together. So I want to see in how many ways I can arrange the letters so that the letter H and S is in a one block. They are arranged together. So if this creates a block H and S, then I have 1, 2, 3, 4 blocks that I need to now arrange. Okay, not 5 anymore, but 4 of them, because H and S must move as a unit. So I have 4 factorial ways to arrange my blocks. Now that's almost correct. My favorable event is not only 4 factorial, because inside that block you have a letter H and S, and they can be rearranged as S and H. So as my massive block moves, I have also 2 factorial ways of moving inside this block. I hope it's making a little bit sense. Think about the textbook example that you probably did in class. There were 3 French books, there were 4 German books, and let's say we've got 2 Portuguese books that we have to arrange on the shelf. In how many ways we can arrange all of them in total? Well, in total, I have 9 different objects. So I can arrange it in 9 factorial ways in total. But what happens if I want to make sure that books of the same language end up together? Now, in this way, we create blocks. I have a block with the French books, block with the German books, and a block with the Portuguese books. So it is actually moving 3 blocks, 3 bricks put all together. So if I want to look at the number of ways in which my books can end up so the languages are together, I'm actually moving 3 bricks. Okay, I hope you said but. Inside my French brick, I can arrange 3 different French books. Inside my German brick, I can arrange 4 German books. And inside my Portuguese brick, I can arrange my Portuguese books. under the condition that they are all different. So it is about grouping, it's about creating groups, it's about creating blocks or bricks and then moving it around together. Pause it, think about it, watch it again if necessary, and think about bricks, making blocks, tying the objects together with a rope so they move as one. Let's look at the next word. And the next word I would like to look at is a word hypothesis. Okay, also mathematical word, but you've done statistics, you've done mathematics, you've done parallelogram, so we can look at hypotheses. And your typical questions: in how many ways all letters in a word hypothesis can be arranged? Right, so if I look at my letters, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 objects, 10 letters that I am, and that's a key word, is arranging. Okay, for the factorial, we're arranging. However, this word is different to the word maths because there we had 5 different objects. In this word, you have 2 identical letter S. So if I swap this S around, makes no difference to my word. What else I have? I have 2 identical letters H. So if I want to answer a first question, in how many ways the letters can be arranged, then the total number of ways is not 10 factorial, because 10 factorial will include swapping this H together and S's together, and that's not a different word, which means that we have to get rid of repetitions. So I've got 2 S's and 2 H that I have to get rid of, so I have to divide by it in order to get the total number of options. Use your calculators, determine the total number of options. We're not talking probability, we are talking only the number of options. Right, so now this is easy. I hope you agree that this is easy, but we would like to look at some other questions, maybe slightly more complex questions. So let's look at number 2. In question 2, I have to look at different ways that the letters can be arranged so the vowels are always next to each other. The vowels are together. So in the 10 letters, I have how many vowels? 1, 2, 3. I've got 3 vowels that must be together. O, E, I. Now they create a block, okay? So this is my block, this is my brick. They must always move together. They must be next to each other. So if I remove 3 letters out of 10 letters, that means I've got another 7. Okay, 1, 2, 3, 4, 5, 6, 7 letters left that are going to be moving alone. Therefore, how many objects am I going to be moving? I will be moving 8 objects. The 1 brick and those single letters in here. So I have 8 factorial ways to arrange it. So this brick can be here, can be in between there. In total, I will be moving 8 objects. So I can move it in n factorial ways. But, okay, but what but? Inside my brick, I have 3 different objects. So as my brick is moving between the objects, the letters inside that brick are different objects that are moving in 3 factorial ways. So the number of favorable events, and the favorable event is when the vowels are always next to each other, is 8 factorial times 3 factorial, which you can find the answer. So if the question for us in the test or exam, if there is a question, what's the probability that all the vowels are together, then it will be my favorable event divided by total number of possible events. And because we're building such a fraction on top of fraction, it's definitely easier to operate with the total numbers. Pause it, think about it. Go back to maths, see how the example there differ, how we created a block, because we're going now to look at the most complex questions when it comes to arranging different objects. Okay, so our most complex question on the word hypotheses is a question where you are asked to look for number of ways in our given word in which we can arrange the letters so the letters H will not end up next to each other. Okay, so we think that it's not that difficult to write them out. So I will have H, 8 letters, and another H. I can have H, I can have 6 letters, H, and the letters. Then I can move this H here and there. Boys, do you understand? It's going to take us forever to think about the total number of ways in which we can arrange it so the letters will not end up next to each other. Okay, so what about a different question, a complement question? What about if the question is in how many ways you can arrange the letters in the given word so the 2 letters H will always be next to each other? Never next to each other, always next to each other will be a complement. Okay, I hope you think about a block, creating a block with the 2 letters H in it, so they always together. So if my word had 10 letters and I take away the 2H, I have 8 letters left to manipulate. If I manipulate 8 letters and the brick and the block with the H's inside, in how many ways I can arrange those objects? I hope you did say that we can arrange it in 9 factorial ways. Do I have a but here? Do I have, yeah, but what about inside? Do I have it? Do I need to look at what's happening inside here? The objects, the 2 letters H, are identical. So whether I put a first H and then the second H, or I take a second H and then a first H, it's not a new arrangement. So we don't have times 2 factorial here because the letters are identical. Therefore, the number of ways in which I can arrange it so the letters W are always together is 9 factorial ways. I hope you can get that. If you can't, go back to the word maths, go back to number 2 of this example that we just looked at. Okay, but you will say, no, that's great with the H's, but we were asked not to end up. Now, not to end up and the complement always end up. Now remember, in statistics, in order to calculate the probability of an event, we can always do 1 minus probability of a complement to A. Now we're not looking at the probability, but I can use the same concept. So the number of events or the number of options that the letters are not next to each other It's obviously the total number of options minus the complement of not together, which is always together. Always together. Okay. Think about it, positive necessary, but we are looking at the number of options for which we are not having the two letters together will be the total one. What was the total? Total was 10 factorial over twice h twice s minus the number of ways in which they are always together, and that is 9 factorial ways. Calculate this out, you can get the answer. This is the most difficult question that you can get on this section. And if you can at least look at the complement of what they are asking you, then you will be able to answer all the questions with the words and with the arrangement of the objects in your matric paper. Okay, so how the letters or the problems with the letters can be used in the word problems in this section with probability and with number of options. Now remember about bricks, remember about blocks, French, Portuguese, German books, all the word hypotheses, which is based on the same concept. And here comes the question that can be so easily asked in your exams. So instead of objects, I am talking about girls and boys. So I have 4 different girls from Girls High. I have 7 different girls from Affy's, Macy's, and I have 6 boys from Boys High. Okay, German books, French books, Portuguese books. They're all different books. They're all different objects. They're going to the concert together. And the simple question, the first question is, in how many ways can all be seated in a row? Okay, so the question is total number of ways that these people can be seated. So if I look at the total number of different objects, we have how many different objects? We have 17 different objects, so it will be 17 factorial. And as you press it on your calculator, you can see how huge number it is to just sit them together without any restrictions. But I want to think about some restrictions and some grouping. So question 2 in here is, what's the probability that all girls will be seated together? Okay, all girls must be seated together. So what must I do with the girls? I must take all the girls and make them a single block. So if I make all the girls a single block, how many objects inside the block I have? Inside the block, I have 11 different objects, 11 different girls. I still have 6 boys. 1, 2, 3, 4, 5, 6. So those ones are my 6 boys from Boys High. So if I want to sit all the girls together, what's the probability that they will end up together? But first, I need to look at what's the number of favorite options so that all girls sit together. What do you think it will be? I've got a brick that must move together and 6 boys. So I'm moving 7 different objects. Is that all? Well, I hope again that you say no, because inside the brick, I still have 11 girls that can move around, which means that the probability of my favorable event, which in this case is all girls will be seated together, is 7 factorial times 11 factorial over the total number of possible events, which is 17 factorial. Press your calculators write the answer. Okay, I hope you understand. I hope you can make a connection to the bricks, the French, German, Portuguese, creating a bricks, putting things together, tying them up so they do not move. Okay, and now our best of the best of the questions, question 3. What about this one? One girl from Girls High, one of them, refuses to sit to a girl from Afis. Okay, now I've got lots of people, so there will have to be lots of options when I start separating those girls. So we must find an easier way than to just write out all the possible options where these two girls do not sit next to each other. Do not sit. Think about it. Hopefully you said that this is a similar to our problem with putting two letters H separately. So we can look at the option of putting those two girls together first. So I have a girl from Girls High and I have girl from Afis. They are together. So how many other people do I have left? I have left 15 other people that can be seated at random. So if these two girls have to always sit together, then I'm moving 16 different objects. But here we've got our but. The two girls are different, so inside the brick I have 2 factorial options also. What this represents? This represents the event that the two girls are always together. So if I want to look at not together, what must I do? Okay, if I want to look at the number of ways that they're not seated together, then it will be the total number of ways minus the number of ways that they are always together. Now, what was my total number of ways? Total number of ways was 17 factorial. So I have to subtract number of ways that they always together. Calculate this out and you find your answer. So this presentation started with quite a simple word and a simple grouping. Then we went to the hypotheses, the word hypotheses. You can practice similar examples on parallelogram, on mathematics, on statistics. And then we looked at arranging people, arranging teams, squash team, tennis team, and rugby team on the same bus, and they're going to watch organ performance. In how many ways you can sit them together so they sit by teams. It gives you some idea, it gives you some options. Please pause it, look at this again. I hope that it was quite helpful. Good luck with these questions.